Hello, this is a video for the report of the class Computer Network. It's a survey of data center networking, DCN, infrastructure and operation from UNT. The internet services have a growing demand that it must be supported by the internet network. The basic unit of these services is the internet server. This server must be allocated in a special building called that data center, where there is a centralized environment with good network connectivity, security, and continually power supply. The large number of computers or servers placed in the data center are creating a big network called Data Center Network, DCN. Compared with a simple local area network, LAN, the DCN has different challenges and requirements. One of the requirements is the large scale. Normally, an actual data center may contain thousands of computers or servers, and they are constantly growing in an exponential rate. This implies an increase of interconnection, cost, and reliability. The second requirement is the variety of applications. Internet networks present a lot of variety of applications, with web search, with mail, games online, database servers, FTP servers, and distributed application for file sharing or execution engines. This implies different type of traffic, priority, and security for each application. Other one is the high energy consumption. Is one of the issues of the actual data center is the energy consumption. Not only the servers are every day smaller, they have more power and consume more power. The networking devices consume a lot of energy too, and in the future it's likely that this consume increase. The last one is the strict service requirements. The service provided in internet is 24/7, so the robustness is one of the most important challenges in the data centers. Failures may happen, and the monitorization and fast failure recovery are mandatory in that situation. There are a lot of studies of the data center in the academia and industry relative to the infrastructure and operation aspect. We're going to watch now in the next slide. In the data center network infrastructure, we have the transmission technologies. We have three of them. One is the electrical cable, another one is the optical fiber, and the other one is the radio wave for wireless. Okay, the electrical cable, normally the speed is 1 gigabyte to 10 gigabytes. The range is only 100 meters. It's only for the normally it's for the intra DCN. The optical fiber has a high speed. Is a better solution. Now it's increasing in the use in the data centers, and the speed is for 40 gigabytes to 100 gigabytes. The range is 10 kilometers, and is used for intra and inter DCN. And finally, the radio wave or wireless solution is an optional solution. The maximum speed normally is 7 gigabytes, and the range is 10 meters. Is very internal in the data center. Is intra data center, and normally we use the antenna is in the top of the rack, but maybe you have normally in the data center they are very sensitive to the radio frequency interference. Maybe the solution is not good in every case. Now we are going to speak about the intra data center networks. We are going to speak now about the electrical element-based topology. Normally, the use of electrical topology present a lot of advantage. That is the compatibility and the cost. It's very, very cheap, and it's very know the technology and it's easy to implement it. Normally, this technology is focused on cable complexity, big section bandwidth, fault tolerance, hop distance, upgrade, and construction cost. We are going to speak now about the switch-centric topology. We have three basic elements. Normally, the basic construction is the FAT tree. Is very common. The 480 FAT tree. There are three layers. In fact, there are 4 layers: the core, aggregation, edge, and server. The advantage of this technology is that the switches may be identical and cheap, and the problem is the cable complexity. The BL2 top architecture that is in the middle is similar concept to the FAT tree with the same layers. And the difference is in that each layer, so that each edge switch is connected to 2 aggregation switches. You can see in the graph. This reduces the number of cables and increase the high speed of the connections. The other one is the jellyfish architecture. Is a random construction in the edge layer, and it needs a few hubs to connect to more servers than in the FAT tree architecture. In the server-centered architectures, the servers are the most important part. In this case, the routing intelligence and interconnection take more importance in the router part than in the switches. You see the question, the part A, sorry, is we have the D-cell topology, and the advantage of this construction is its scalability with a few ports and NIC servers and few switches. The second one is the B-cube topology. It's really similar to D-cell. The other one is the level 1 FICON. In this topology, we have a limit on NIC ports and the limit is 2 for each server. To do the comparison of electrical elements based on topology, we have several indicators in which the electrical elements topology are focused. They are listed in this table. We have the metrics and indicators. We have the scalability, construction cost, capacity, latency, cable complexity, and robustness. Electrical optical elements topologies. In this case, the bandwidth demand is increasing every year, and the decreasing of the cost of the optical devices that it produces, that the optical switching is the new solution for that. In this graph, we can see 1, 2, 3, 4 solutions for this technology. One is the A is CTOG, is based in the tree-based topology. In this case, the switches are connected to an optical network, and the traffic is analyzed using buffers, and the packets are redirected to a different VLANs. One for electrical part and another for the optical switches. The second one is the B-Helios. The construction is 2-level multi-router tree of both switches and core switches. Core switches in the top connect to the electrical and optical networks. It's based in the max weighted matching for the 2 networks. The third one is the OSA or OSA, is in the right part of the graph. In this case, the switches are connected only by optical communication. It uses a multiplexer, and the multiplexer for send and receive fiber completely separate. In this case, there are one 1x4 WSS that receive the max signal and forward to 4 ports according for the wavelength. The 16x16 bipartite MEMS optical switch admit inputs in its port to any other its outputs. The couple mix signals with different wavelengths into the fiber, and the max separates the signal to different fibers. These two elements, WCC and MEMS, are reconfigured. You can reconfigure it. The fourth one is the MORDIA. The MORDIA is Microsecond Optical Research Data Center Interconnect Architecture, and in this case, it's totally similar. It's very similar to OSA, the last one, but it uses an unidirectional ring topology. The electrical, in this case, the electrical wireless element topologies is the studios are based in 60 gigahertz radio, where the most important parameters are the link stability, signal propagation, and spatial reuse. The hybrid network technology is called flyways. There are three types of this technology. One is 2D flyways. The Tor routers have a directional antenna transmitting wireless signal with 16 GHz devices. In the second one is the 3D flyways. In the top of the racks are placed wireless devices with rotatable directional antennas. There are ceiling reflectors that acts as a mirror reflecting signals. The last one is the Firefly. It's similar to 3D flyways and uses the oversubscribed network. It has high bandwidth, lower interference, and long range. In inter-data center networks, we can select the data center. We can do the choice attending to several factors. One is the geography, the place that you can is the data center. The other one is the electricity. The cost of the electricity is very important. Other one is the connectivity. Is other important factor. How many networks you have it. How many different networks for redundant connections. And the other one is the business. Business is the distance. How is the distance with your customers? The customer is one of the most important part of your business. The data center network operation. In the data center, the data transport for source to destination must be ensured. The main goals are bandwidth proportionality, bandwidth guarantee, energy efficiency, and balanced load. In this table, you can see what is the objectives in data center operation. One is the network utilization, the other one is bandwidth sharing, and the other one is energy consumption, and last one is network maintenance. And you can control that objectives with the traffic control. We have a path selection, rate control, and priority management. Every proposal has different solutions, and you can read the paper to get more details. And now we are going to see the opportunities or new research we can do in this topic. One is the multicast. Is when you send data for one source to several destinations. This saves traffic and release the server to send the same repeat packet every time. But technologically, this solution is really very problematic. It gives a lot of problems. The application layer multicast over unicast is an option that it works, easy to manage and implement it. The cross-system optimization is a cooling system and server system are other important systems additional to the network system. The utilization of virtual machines and migration of virtual machines facilitates the balance between energy efficiency and traffic engineering. The third one is the modular data center. The big companies like IBM, HP, they provide modular data center, and they put a few thousand of servers in container network topology. The other one is the merchant silicon switch. Is the system that helps to construct a big switch with a huge NIC ports, reducing the cable complexity. And finally, the software-defined network in data center (SDN) is the solution in a near future, decoupling the control plane from the data plane, and it allows the programming of the network application. SDN provides a very efficient configuration, higher flexibility, and better performance for the network designs. And this is the end. Thank you for watching.